how long does it take for half the carbon to remain? Okay, so that's what half-life means. So does anybody have any idea what I should use to replace my Y to represent half of my initial amount of carbon being used?
Would it be 50?
Yeah, so it's not going to be just 50. We want 50% of the initial amount. So what fraction can I multiply by C0 to show that I'm having 50% of my initial amount? So this is a little tricky. What I want to do is I want to just write it in terms of the variable I used for my initial amount. So this is half of my initial amount of carbon. So I'm going to set, so we would set Y equal to 1/2 C0. Okay, and then we're solving for T. Now notice I can divide by C0 on both sides. And I can cancel those C0s out. So I end up with the function 1/2 equals 1 minus 0.035 to the T power. And this 0.035, I could rewrite as 0.965. They're the same. What questions do you have? So if you used highlighters with me yesterday, I'm going to go ahead and use highlighters again. I believe I used pink for my base. And I used blue, I think, for my answer. No, blue is my exponent. So my T, that is really dark. Hold on. So I have T right here. Okay. And then purple was my answer. I want to rewrite this as a logarithm so that I can isolate T. So Jason, your mic still doesn't work. Yvonne, are you here?
Yes.
So can you help me rewrite this as a logarithm instead of an exponential function?
Mm-hmm.
What am I going to write?
Log T.
What's the base of my log?
0.
Yeah, 0.965. And then what goes inside? So let's flip over real quick. When we went from an exponent to a logarithm, the purple went inside of my logarithm.
The 1/2.
Yeah, so 1/2 goes here. And we set that equal to our exponent, which was
The T.
Yeah. So now we've solved for T using our conversion between exponents and logarithms. Isn't that sweet? Okay, so now we could take our calculator, all right, and we can type in, so let me get rid of this, log, let me find my function, log, my base needs to be 0.965. This stuff inside the parentheses was 1/2. And then that's it. So all of that should be equal to t. So I should get that my t value is going to be about 19.5 minutes. Okay. So what I did was I combined my knowledge about setting up exponential equations from before. I rearranged my exponential equation so that I just had an answer over here, my base and my exponent on the right, and I rewrote it as a logarithm to solve for t. What questions do you guys have? Okay, so we don't have too much time left. So I want you guys to do at least number 2 as a you do. And I will post solutions at the end of class today for all the problems on the back of this in case you want extra practice. Okay, so I want you guys to do that one as a you do. We did the first one together. If you didn't get everything copied down, I'll post the final solutions. Okay. We're going to move on to our key features. Okay, it's important that we cover those real quick today. Don't have too much time left. All right, and we're going to do a few graphing problems, and you're going to finish the graphing problems on the back for your asynchronous time and for your homework. Okay, so first we're going to go through some of our descriptions, our little definitions of our key features. So an x-intercept is going to be where, I should have asked you guys this, the graph crosses the x-axis, crosses the x-axis. Okay, and you can do this 2 ways. The first way is to set y1 equal to 0 in your calculator, set y2 equal to your function, okay, and then find the intersection. The second way is to set y equal to 0, change to an exponent, and solve. Okay, that's kind of what we did in the last problem. So an example here, I'll show you on the calculator. You just type in, oops, let me move this out of the way, I'm sorry. So we're going to type in the log base 10 of x plus 2 minus 1. And on Desmos, it will show you that the x-intercept is right there. You can just click on it and write in 8, 0. Okay, what questions do you have about the x-intercept? Okay, if there are no questions about the x-intercept, we'll go ahead and do the vertical asymptote. So it says that for vertical asymptote, it's going to be in the form x equals a number, okay? And it's a vertical line. All right, and the graph doesn't cross it. All right, and let me see who's trying to get in 10 minutes before classes. All right, to find it, we set the inside of the log equal to 0 and solve for x. So here, we would take the inside of the logarithm, x plus 2, set it to equal to 0. Subtract 2 on each side to get that x equals -2 is my vertical asymptote. Okay, so all we did, so set the inside of the log is this x plus 2, and we set it equal to 0. All right. So the domain, our description is going to be the that have a corresponding y value. Okay, and we find it will either be the vertical asymptote to infinity, or if there is a negative in front of it, then it's going to be from -infinity to our vertical asymptote. So, 4. Okay, and the VA just stands for a vertical asymptote. So for this function, there's no negative out in front of our logarithm. So it should be the vertical asymptote, which is -2 to positive infinity. Okay, and the range is going to be all the y values, right? We should have all real numbers for this every time. All right, which can be written as this double barred R, or from -infinity to positive infinity. All right, and it's always just going to be from -infinity to positive infinity. Okay, and this is the general form of our logarithmic function. What questions do you guys have about those key features? Those are the key features that we're going to care about for logarithmic functions. So just like all of our other functions, A is going to represent our vertical stretch or shrink. Our H is going to be our horizontal shift. And our K is going to be our vertical shift. Is it CAL or CLE for vertical? Nobody knows? It's CAL. Okay, so vertical shift.